Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video, we write a Java program to validate a credit card number using Luhn algorithm. So before we begin, it is a request that if you like this video, if you find this helpful, please do subscribe to my channel, because out of 100 viewers, only one is subscribed, and your subscription is very important for me. So please do subscribe to my channel. So let's begin. So we are given a string S, okay, which is a credit card number, and we need to check if this string S contains a valid 16-digit credit card number or not. That's a problem. Okay, so I'm going to write the pseudocode here. So I'll say validate cc and takes a string S. Alright, so the first thing we need to do is make sure that it is of 16 digits, because a credit card number is of 16 digits. Okay, and then we make sure that it contains only digits. Okay, so the first check is, so make sure length of S is 16. Okay, second thing, make sure S consists only of digits. Okay, only if these two conditions are confirmed that we can say that it is a 16-digit number, and then we can use Luhn algorithm on that. Okay, because this algorithm is defined for a 16-digit number, so we have to make sure that the string is 16 digits only. Okay, alright, so I can use the dot length, okay, of S to check if the length is 16 or not. I need to write a helper method to check if it consists only of digits. So I say boolean contains only digits, string S. So this method takes a string S and returns true if S is only made up of digits, otherwise it returns false. Okay, to check that, we iterate the string. Okay, right, and we need to make sure that each character is only a digit. And to check if a character is a digit or not, I'm going to use the isDigit method of character class. So I'm going to get the ith character in this variable ch, okay, using the caret method. And if not character is digit, passing ch. Okay, so isDigit is a static function in character class, okay, already defined in Java, that takes a character and returns true if this is a digit. Okay, if this is the case, okay, I return false. Okay, and finally I return true. That is, I will iterate the entire string. I will pick up the character at each index in this string and check if it is not a digit. That is, if this character at ith index is not a digit, I return a false. Okay, finally I return true, because if this condition is not true for any of the indices, it means all the indices were a digit. Okay, alright, so this is my helper method that makes sure that S consists of only of digits. Okay, so let me write this boolean is valid cc takes a string S. Okay, first thing is to make sure if the length is 16. So if S dot length is not equal to 16, return false. Okay, then it does not contain digits. If not contains only digits, okay, takes the string S and returns false. Okay, so passing this string S, if this contains only digits, function returns false. Okay, alright, I return false because this S has to contain only digits to work for Luhn algorithm. Okay, now that we are here, we use Luhn algorithm. Okay, and now I'll tell you what Luhn algorithm is. This is just the string pre-processing to make sure that we can run Luhn algorithm on string S. Okay, passing these two S. Okay, so if I take a string of length 16, so when these two steps are processed, okay, which are written in code here, and I come here, I make sure that I get a string of length 16 containing digits only. So I've written a sample string of length 16, okay, indices are 0 to 15. Alright, so Luhn algorithm says that I start with a sum equal to 0. Okay, I start iterating this 16-digit number from the right hand side. Okay, alright, and I go left. Okay, and I pick up each digit and add it to the sum. Okay, so when I is at 15, okay, it is at the last index, my digit is 5, my sum is going to be 0 plus 5 equal to 5. Alright, okay. I use this index, I move on to the next one. Luhn algorithm also says that starting from the second last index and every alternate digit. Okay, starting from the second last index, every alternate digit must be doubled before adding. Okay, so this is into 2, 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 this is into 2. Okay, so when I is at 14, your digit is 4. Okay, 4 into 2 is done. Okay, so it becomes 8, and 8 is then added to the sums. Okay, so 5 plus 8 equal to 13. Because at index 14 I need to double this digit. Okay, I move on to the next index. I come to 13. I come at 13. I get 3 as my digit. Okay, I don't need to double this one. Okay, so I add 3 as it is. So 13 plus 3, old sum plus 3, I get 16. Okay, I come to 12. Okay, I becomes 12. At 12 I need to double. My digit is 2. I double it, I get 4. I add 16. Okay, which is the old sum. I add 4, I get 20. Okay, I reduce, I come here. I becomes 11. Digit here is 1. I don't need to double this one. I add it as it is. 20 plus 1, I get 21. Okay, I comes here. I becomes 10. When I is 10, I get digit as 0. I multiply it by 2, I get 0. Okay, I add it to sum. 21 plus 0 is 21. I is reduced. I come here. I come here. At index 9, I have digit as 9. I add 9 as it is. This does not have to be double. 21 plus 9 is 30. Okay, I comes here. I is 8. Digit at I is 8. Okay, I double it. I get 16. Okay. One final point of Luhn algorithm is that when you get a number which is of 2 digits, that is when you multiply this 8 by 2, you get 2 digits, you have to add individual digits. So this is 1 plus 6 equal to 7. So this basically counts as 1 plus 6 equal to 7. And then you add 7 to the sum, so it becomes 30 plus 7 equal to 37. Alright, and this goes for all the cases where you double and you get a digit and you get a number which is 2 digits. Okay, so when I moves to 7, okay, so 7 is added to 37 plus 7 is 44. Okay, so, alright, I moves here. Okay, I 6, this has to be double, this will become 12. Now since this is not a single digit, we do 1 plus 2 is equal to 3. Okay, so 44 plus 3 equal to 47. Okay, I comes here, I becomes 5, digit is 5. This is not double, added as it is. 47 plus 5 is 52. Okay, I comes here, I becomes 4. 4 is double. Okay, now after doubling I get a single digit only. Whenever I double and I get a single digit, I add it as it is. So 52 plus 8 is 60. So I comes here now. I is 3. Digit is 3. Okay, you do 60 plus 3, 63. Okay, I comes 2. Okay, this has to be double. 2 into 2 equal to 4. 63 plus 4 is 67. Okay, I comes here. Okay, I is 1, digit is 1. It is added as it is. 68. I go 0. Digit is 0. 68 plus 0 is 68. Okay, alright. Final thing is that when you get this sum, if sum percent 10 is 0, return true. That is after this processing of the sum, that is we iterated this string from right to left and we doubled every alternate number that and every alternate digit that we had. Okay, following this rule. Okay, the sum that you get finally must be divisible by 10. Okay, if it is, then it is a valid credit card number, and that is what Luhn algorithm is. Okay, all right. So this is what we code. We start with the last index, go to the first one. I say for int I equal to s dot length minus 1, I greater than equal to 0, I minus minus. Okay, I have to start with the sum equal to 0, and every other digit starting from the second last I have to double. So I start with the boolean flag as false. Okay, so when my I is here, my flag is false, and when my flag will be true, I will make this digit to double. Okay, so I get my digit as int d is s dot char at I minus 0. So this basically is the standard trick to get the digit from the corresponding single character that stores a digit. That is, if I have say 1, I need to get integer 1. This will be a character, right? Single character. I need to get digit 1. So what I do 1 minus 0, so I get 1. Because in Java, single characters are stored at ASCII values. So this has an integer value associated with this. This has an integer value associated with this. So 0 is basically 48. Okay. 1 is 49, 2 is 50, 3 is 51, and 4 is 52, and so on. So when you do 1 minus 0, you do 49 minus 48, you get 1. When you do 2 minus 0, you do 50 minus 48, you get 2. You do 3 minus 0, you do 51 minus 48, you get 3. So that is how you convert the single character which contains a digit into an integer digit, which is what I am doing here. Okay, subtracting 0 in a single character, okay, from this given character which is a digit. Okay, so my current value of I here, okay, which is 15, I get my D as 5. So when I do 5 minus 0, okay, I basically do 5 is going to be 53. So 53 minus 48, I get 5. So this single character 5 is converted to digit 5. Okay, I have the digit. So if my flag is enabled, I double it. So if flag, okay, I do D is equals to D into 2. I double digit. And I also make sure that after if doubling, I get 2 digits. I get a double digit number. I add individual digits. If I get 8 into 2, 16, I should make it 7. How do you do that? You basically do D minus 9. How? So from 16, you need to get 1 plus 6 equal to 7. You can do 16 minus 9, that will give you 7. Same thing. For 15, you need to do 1 plus 5, which will give you 6. From 15, you can subtract 9, you can get 6. Okay. From 10, you need to do 1 plus 0 is equal to 1. From 10, you can do minus 9 equal to 1. So if this value is greater than 9, you do minus 9. Okay. So if D is greater than 9, okay, I do D equal to D minus 9. Okay. Alright, and this flag if ends here. Okay. This is to make sure that all 2-digit double values are converted to single digits. Okay. Alright. Okay. So I do sum plus equal to D. Okay. And after I add sum, I have to switch the flag. I say flag is not flag. Okay. So why am I doing this? When I is at the last index, my flag is false. Okay. When my flag is false, nothing happens to D. D is not double. D is added as it is. Okay. So when my I is 15, my flag is false. Okay. I is here. Okay. I do flag is not flag. For next value of I, flag becomes true. So when I moves here, flag becomes true. So this digit is double. Okay. So if D was 4, D became 8. Okay. And D greater than 9 will be false for D equal to 8. So to sum, you add D, which is 8. Excuse me. So when I is 14, your flag becomes 2 and you double the digit and add it to the sum. Okay. Alright. And then you reset the flag. So when for I equal to 13, flag becomes false. Okay. I comes here. You add D as it is. You add 3 as it is. Okay. Then again when you move back to the next value of I at 12. Okay. I becomes 12. Flag is not flag. You reset flag to true and digit is double before adding. Okay. Final thing we need to check is if sub %10 is equal to 0. So return sum %10 double equal to 0. So if this condition is true, it means the string S which contained 16 digits is a valid credit card number. Okay. So let me try run this for a actual credit card, valid credit card number. Okay. So let me remove this. So this is a valid credit card number. Okay. 16 digit, and I'm going to check if Luhn algorithm is going to work on it. And obviously this is not my credit card number. This is the first number that I googled and I got. Okay. So in our code, till here check is going to be true because 16 digits and contains only digits. Okay, so we come here to check. We have sum, we have flag, we have I, and we have D. Those are all the variables we have, right? Okay. Sum starts with 0, flag starts at false. Okay. I starts at s dot length minus 1. S dot length is 16. I starts at 15. Okay. Alright. I starts at 15 and goes all the way till 0, decrementing my 1. Okay. D is s dot caret I minus 0. D is s dot caret I. S dot caret I is this 1. So D is 1 minus 0, which is 1. Okay. If flag is false, so I'll add a condition if flag. Okay. So this is false. Okay. Alright. If flag is false, I move s dot length. Okay. S dot length is okay. If flag is false, okay, so nothing happens. Sum plus equal to D. Sum is 0 plus 1 equal to 1. Okay, you go back and flag is not flag becomes true. Okay, we move to the next value of I is 14. Okay, I was at 15, I comes at 14, I is at 14, right? Okay, I is at 14, D is s dot caret I, which is 8 minus 0, which is 8. Right? If flag is true, okay, so you do D is equals to D into 2. 8 into 2 equal to 16. If D is greater than 9, true. Okay, D is D minus 9. 16 minus 9 equal to 7. Okay, then you add 7 to sum. Sum becomes 1 plus 7 equal to 8. After sum equal to 2, flag is not false, flag is now false. Okay, I moved on to the next value. I is 13. I is 13. D will be 8. Okay, flag is false. Okay, if flag is false, so you add 8 to sum. 8 plus 8 is 16. Okay, flag is not false, flag becomes true now. Next value of I goes to 12. Okay, I comes here. At I 12, okay, I have 1. D is 1. Okay, D is 1 if flag is 2, you do D equal to D into 2, D becomes 2. Okay, D is greater than 9 is false, sum plus D, 16 plus 2, 18. Okay, flag is not flag becomes false. Okay, next value of I becomes 11. I comes here. Okay, I is 11, D is 8. Okay, D is 8 if flag is false, sum plus D, sum is 18 plus if flag is false, 18 plus 8 is 26. Okay, flag is not false, flag becomes true. Okay, I comes here, I becomes 10. Okay, D at 10 is 8 again. Okay, if flag is true, so when flag is true, we do D into 2, 8 into 2, 16, then we add do 16 minus 9, so into 2 minus 9 is equal to 7. Okay, add 7 to sum. 26 plus 7 is 33. Okay, 26 plus 7 is 33. Flag is not flag becomes false. Next value of I becomes 9. Okay, this is 8 again. Okay, if flag is false, okay, add 8. 33 plus 8, 41. False becomes true. Next value of I, 8. Okay, I becomes 8. It is 8 again. Okay, alright, D is 8. Since this is true, we do this thing into 2 minus 9 again. 7 because this is true. Alright, this was false and this was true. Okay, you add 7. 41 plus 7 is 48. This becomes false. Okay, next value of I is 7. I is 7. Okay, I is 8 again. Okay, this is false. You add 8 as it is. 48 plus 8 is 56. Okay, this becomes true. Next value of I is 6. I comes here. It is 8 again. Okay, since this is true, we do into 2 minus 9 equal to 7. 56 plus 7 is 63. Okay, this becomes false. Okay, next value of I is 5. Okay, 8 again. Okay, this is false. We add 8. 63 plus 8 is 71. Okay, this becomes true. Okay, next value of I is 4. I comes here. Okay, again 8. Okay, since this is true, we do into 2 minus 9 equal to 7. This is true. Okay, since this is true, we do this. We add 7. 71 plus 7, we get 78. This becomes false. Next value of I is 3. Okay, next value of I is 3. Digit here is 2. Okay, since this is false, we add 2 as it is. We do 78 plus 2 is 80. Okay, this becomes true. Okay, next value of I is 2. I comes here. D is 1. Okay, D is 1. Okay, and since this is 2, we do into 2 equal to 2. D greater than 9 is false, so we add 2. 80 plus 2, we do 82. This becomes false. Okay, we go to next value of I, which is 1. Okay, at 1 it is D is 0, so this is false. You add 0. 82 plus 0 is 82. This becomes true. Next index is 0. Next index is 0. Okay, D is 4. Since this is true, into 2 is 8. Okay, you add 8 to 82. 82 plus 8 is 90. Okay, 90. Okay, we use all the values of I. Okay, loop closes. Okay, this becomes false. Okay, it's redundant now. Okay, this sum is 90. Sorry, 90% 10 is equal to 0. So return value is true. So this is a valid credit card number. So this was the solution to this problem, and I hope this was helpful. Okay, and this was the -9 was the trick. Okay, so that you could add individual digits. Obviously you won't get 15, but if you get 14, it is going to give you the same as 1 plus 4 equal to 14 minus 9. Okay, same as. Okay, all right. So before I move on to running this on a system, it is a request that if you like this video, if you find this helpful, please do subscribe to my channel, and let's move on to running this on a system now. So this is the code that we discussed and wrote, and this is the function that takes a credit card number as a string and returns true if this is a valid credit card number. So this first checks if this is of length 16 or not, and then it checks if S contains only digits. Okay, so when we are here, we use Luhn algorithm. Okay, because we are sure that the string is a 16-digit number. Okay, so this is implementing the Luhn algorithm, and I have written the algorithm in simple steps here. Okay, all right, and I have taken some credit card numbers. Again, these are not my credit card numbers, they are just from the internet, and this is the credit card number that I took when I was explaining the Luhn algorithm. Okay, so this is invalid. Okay, so let me run this. Java C, Java. So you see this are all valid credit card numbers, and obviously the last one, the sample that we took in explanation, is not the valid credit card number. So let me just print the sum so that you get an idea of what the sum is. Okay, plus sum. Okay, for each case before we check. Okay, so sum is 90 for this one, sum is 70 for this one, sum is 50, for this one sum is 20, for this one sum is 40, and for this one, as we checked, sum is 68. All right. Okay, so this was the solution to this problem, and I hope this was helpful. So if you found this video, if you like this video, please like my video, share my channel, subscribe to my channel, and you can also let me know in the comments if there was something in this video that you did not like at all, or there is something that you absolutely disliked. I'm absolutely open to suggestions, so please let me know. And you can also post in the comments if there is a question you want me to solve, or if there is a concept you want me to discuss. Thank you.